Okay, welcome back. So today I'm going to go over the video demonstrations for the fourth set of observations that we're doing on our architecture unit. So we're just going to be looking at how those stone forms were limited, the different ways in which they failed. All right, so with that, I will jump into the video. So first demonstration, I'll try and pause it and make notations where I think it's important. So, need to play it. There we go. Now it's playing. Okay, so here we see me coming up here. Now, important thing with this first one, what I'm doing here, is I'm actually I'm putting that cube shaped thing in order to this thing right here in order to make sure that when I start putting weight on this post and lintel right here, that's what we have. All the weight will be concentrated in the center and not on the edges. Now, the second demonstration concentrates the weight more on the edges, but we want to see what happens when we concentrate weight on the center. So that's what I'm doing here. So let's go ahead and see what happens. So there's one. A little difficult for me to balance, you can tell. That lintel's not perfectly flat. That happens sometimes. And then there's two. Now, what I want to do, I want to pause briefly right here because I hope you noticed something. I hope this was one of the observations you picked up. What we have right here is we have the bottom of this lintel starting to curve. And the problem is when you start seeing this, it's a very good indication that the structure is near to failing. And the main thing that's going on is what's happening down at the bottom is it's getting stretched. So basically, this side that's getting curved outward is now longer than it normally is. And when we do that, we call this we say that thing is under tension right there. And this is true for wood, true for stone, that if you put these materials under tension, they tend to get a little bit weaker. So what you saw is that eventually this thing snaps. Now in this one, I actually slow it down so that we can actually see where it snaps from. But we'll take a look at that. But we can hopefully see. I think it's the next book where it happens. And then I slow it down, and what you can see right there is it snaps starting right at the bottom. So we'll try and back it up there. Whoops. Okay, here we go. All right, so we'll try and watch that one more time. And there you go. It snaps right from the bottom. Okay, so moving on to demo 2, we'll take a look at what happens when we don't load the center. Another post and lintel, but this time I have the cube off to the side here. It's right there, so not going to. And I can just keep on putting books. So there's the third book, fourth book. Starting to have difficulty balancing because the books are a little bit bigger than the post and lintel. But there's the fifth book, the sixth book, seventh book, and I think that's all I had room for. So, or no, looks like I have one more. The eighth book. All right. So then I start. Oh, no, 9. All right. At that point is where I start taking them down. So we'll pause there really quickly. Now, what I want you to notice is we have a little bit of bowing right there on the bottom. So that thing is under a little bit of tension, which is going to make that portion weaker. But mostly what's going on here is the weight is kind of smushing these two sides together and then sort of smushing down on the two posts as well. Now you can imagine that if we put a lot more weight in, eventually this would start to be under some tension here, and the posts would actually start to eventually be under some tension as well as we started crunching down on them more and more and more. But what we have here in both the lintel and in the post is we have compression. Now, if you're going to, so we have compression on both sides there. If you want these stone structures to to maintain strength, you want to push them under compression. So you don't want them to stretch out. You want them to be pushed together, because when they're under compression, they'll tend to remain a little bit stronger. So this is why this post and lintel, same basic material, can hold a lot more books if I'm making sure that I'm making sure that the structures are being compressed, not necessarily stretched out. Now, eventually, we load it down too much, they will start to be under tension in certain places, and the places that they're under tension will be the places that tend to snap. You can see this if you go break a stick, you go break a piece of wood. When you bow it, it's the side that you're bending, that you're stretching out, that breaks first. So that's something worth keeping in mind there that happens with these guys right here. All right. So another thing to notice, and we'll contrast this when there we go. So the rest of this is just me taking the books off, which is fine. So you can count them. There's 5, 6, removing a tool, 7. Oh, it looks like I had 9. I miscounted. Okay, third demo. So what we have here is, again, a post and lintel. And this time it's pretty wild what I'm doing to it. I made it somewhat exaggerated. But basically what I've done is I've made it so that the right lintel in the video is not on flat ground. So basically this thing is not level. The lintel is not placed on level ground. And basically what that just means is it's not horizontal. If a surface is level, then it's perfectly horizontal. And then, as another consequence of this side right here is not vertical. So I'll put that parentheses, not vertical. This one was not horizontal. The term that's often used in construction when we're talking about vertical is plumb. And that has to do with the tool that was used to measure vertical. And definitely be thinking about that. We'll go into that in the next lecture. But be thinking about what tool could be used to measure whether or not something's vertical. And something kind of bad happens, as you remember, when one of the lintels, even one of them, let alone both of them, are not placed on level ground or are not plumb. They're not perfectly plumb. So if we want to have stable structures, we want to have structures that are both level and plumb, assuming that's the best way to maintain stability there. So one book, the thing collapses. Fair enough. All right, so with this one, we're going to move into corbels. And the first demo is me just doing a basic corbel with these simple foam blocks. You can see all the foam powder off to the side there. And it seems to be fine until I put the 5th block on, and then it collapses. So we'll back up there and look at this one more time. So put the 5th on, and then it collapses. All right. Well, that didn't work out so well. I wanted to pause it. In any event, we'll back up one more time and try and pause it when we get to the last block here. Okay, so basically what's going on is what you can kind of see is that as I put more and more blocks in this corbel, this first block is acting as the support. Now, the problem with making that, you can't just keep extending the corbel more and more over to the side, because eventually the structure is no longer over the support. And when the structure is no longer over the support, like this block certainly is, if we just put this top block over this bottom corbel, it certainly would not stay there. Now, the corbel does negate that a little bit because it is supported by the block underneath it. But eventually, if you try to go too far, the whole corbel just kind of is no longer over its support, and it comes crashing down when the structure is no longer support it. So if you want structures to be stable, you've got to make sure that they are well supported. If they're not well supported, if they start hanging too far away from their supports, then you can have some kind of bad things start to happen here. And not a big deal when it's just foam blocks, but if you have a real architectural structure, that could be a problem. Okay, jumping into the fourth one. This time we're going to look at a corbelled arch and sort of see what happens. Now, I create the corbels with 4 blocks on each side. You can kind of see how that works. It takes me a little while to get it done. I had that smaller block that I was using as a lintel. See me wiping the dust off my hands. So these foam blocks do unfortunately shed quite a bit of dust when you're using them. So what I'm trying to do here is put the fifth object on, and I'm ultimately gonna have to push the things a little bit closer. I'm trying to set it up right, but there we go. Okay, so now we have a corbelled arch. Now, the problem still remains that if the support is too far away, it just comes crashing down. So again, if we have 2 supports now, but we have one here and one here, but if the load is in the middle, if the weight that it has to bear is in the middle and too far away from those supports, it's not going to remain steady here. Okay, so that's one of the problems that we ran into here as well. And we put the weight on. It doesn't last very long. The sides kind of slide out. Now this is going to be more apparent in the next one with a triangular arch, where I just put a basic load on and the sides slide out. So with both the corbel and the triangular arch, I'm going to back up just a little bit, but we see sort of what happens if we have weight put on the center where the supports are off to the sides. Basically what happens is the sides slide out. Now, one way we can start to get around this is we can instead do what I do in the final demo, and that is brace the sides. So we'll wait for demo 6. But what I do in this one is I jump to having 2 textbooks on either side of the triangular arch. And then what is possible is it's possible to actually start loading this triangular arch down because the sides are actually blocked. Okay, so because these sides are blocked by the books, I can now start putting some actual weight on this triangular arch. Now it's a little difficult because I'm not balancing it correctly. I would need a lot more books. And you can see even I start putting too much weight on it, starts pushing and you can see there the bases start to slide, and I put one more book on, and still the bases are gonna slide just like they did before. Okay, so that's what happens when the different ways that these forms can fail. Okay, so go back, go back and answer the questions for the necessary parts, and then jump into the next set of observations. Those will be on the Egyptian achievements in stone architecture, and a big part of the thing you're going to be looking for is the way they overcome these limitations, because they use these forms repeatedly. We're mostly going to be looking at the pyramids. They use these forms repeatedly, and they find ways to sort of overcome some of these limitations that we have with them. So be on the lookout for that when you're doing your next set of observations. Thank you. I'll see you next time.